Alright, so hello and welcome back to the walkthrough series, and in this episode we are going to be looking at the Python implementation for question 3 of 9618 variant 41 of May-June 2023. So let's go ahead and look at the question here. We will be using the source files for this question, namely animaldata.txt and colordata.txt, and these are the files right here. You can see animal data and colordata.txt there. Alright, so let's see the question here. It says that a program implements two stakes using 1D arrays. One stake stores the names of colors, one stake stores the names of animals. So the program contains the following global arrays and variables. So we have two 1D arrays, one called animal and the other one called color. The animal array is going to have a size of 20, and the color array is going to have a size of 10. And we also have 2 pointers for each of the respective arrays, as it were. So our task here is to write program code to declare the global variables and arrays. So let's go ahead and look at the implementation that I have going on here. You see that I'm declaring the two arrays on lines 2 and 3. We are making use of lists actually in Python. So initially they're just going to have values of 20, and they're each going to be of size 20 and 10 respectively as per the requirements. Then for the pointers, they're supposed to be initialized to 0, so we are doing that on lines 4 and 5 there. So of course, you'd go ahead and copy the code and paste it inside of the evidence document. Then moving on to part B, item 1, we have the pseudocode for the function called pushAnimal. You can actually see that the function called pushAnimal has an integer parameter. Rather, it is a string parameter called data2push. It is going to return a boolean. And then, of course, the logic right here is for pushing an element onto the stack, as it were, and if the stack is full, it's not going to push anything. Otherwise, if the stack is not full, then it's going to push the data onto the stack, update the pointer, and return true. So let's go ahead and look at the equivalent Python code for this. So I have that going on between lines 9 and 17 there. You see the function header on line number 9. I'm using annotations to describe what the function takes as parameters and what it returns. So it's going to return a boolean, true or false, and data2push, that is the parameter definition, it's a string. Then of course it's going to make reference to the global animal and animal top pointer of variables for it to be able to push things onto the stack. So the animal is the stack, and the pointer is going to be pointing at the current element or current space free in the animal list, as it were. So yeah, this is the equivalent Python implementation. Again, you're just translating it line by line for the most part, with the exception of this global, because you're making reference of global variables, so you need to make use of the global keyword right there on line 10. But other than that, everything really is just the equivalent of this pseudocode line by line, as it were. So you'd go ahead and copy the code and paste it inside of the evidence document. Then moving on to item number 2, we have a function called popAnimal that's going to return a string, and basically it's simply going to remove an element from the stack or from the list and give it back to the caller, as it were. So we are to implement this functionality in Python. So let me go ahead and come here. So you see that where's my pop? Yeah, this is my pop function right here. So you see that it's going to return a string. We're using annotations on line 21 there alongside the function definition. Then we also have we are making use of the global animal and animal top pointer variables. Then we are checking to see if the pointer is currently pointing at 0, in which case the stack is empty, so we return an empty string. Otherwise, we are going to decrement the pointer, or rather take the value that is currently at the animal pointer and put that inside of that return data variable right there. Then we decrement the value for animal pointer. So the reason why we are making use of animal top pointer -1 is because, let's say the user supplies or wants to remove a variable that's at let's say 20, is it? So the actual index position for that value is actually 19, because remember, index positions are always going to be equal to n-1. That is, so if you have 20 elements in a list, so the indices are going to run from 0 to 19. So that's why we have that -1 going on there on line 17. So having done that, you can go ahead and copy the code and paste it inside of the evidence document. Moving on to item number 3, we have a procedure called read data, and what it does is that it reads the animal names from the animal data.txt file. It's going to use push animal to insert each element or to insert each name onto the stack. Then it's also going to use appropriate exception handling if the file does not exist. So we have to write program code for read data. So coming to the implementation that I have going on here, read data, remember it's not going to return anything, it's just going to unpack the data from the text file into the list, as it were. So what we are doing is we are making reference to the global animal top pointer and the color top pointer, because we are going to be reading the data from both the animal data for the first part. Then later on we are going to have to read the data from the color data.txt file. So in the meantime, you can just ignore this variable for now because we are going to amend it. I actually have a full solution going on here. So let's just focus on this animal top pointer. So what we're doing is we are just resetting the animal top pointer to 0, but of course this is optional. You don't need to reset it because we've already initialized it to 0 right here. Then we are using a try except block to handle any exceptions that might arise from trying to read the file. So that's why inside of our script here, we are making use of the file not found exception right there. And we are also having a general exception when we fail to read data from the file, as it were. That is with this general exception right here on line 49 there. So what we're doing is we're opening the animal.txt file in read mode right there, and we're opening it as animal file. Then we are reading each line from the animal file, and we are taking the current line, stripping any white spaces. After stripping any trailing white spaces, we store that as the animal name inside of this animal name variable. Then if the animal name variable is not empty, then we are going to push it into the array or the list, as it were, or rather it's the stack. We're going to push it onto the stack, as it were. So yeah, that's how we go about it. So having done that, you can go ahead and copy the code and paste it inside of the evidence document. Then we have the function called push color that performs the same function as push animal, but this time around it's going to be pushing a color onto the onto the color stack, as it were. So it's going to perform the same function as same actions as pop animal, but removes the next item from color. So we have to write code for functions push color and pop color. So these are basically the same thing. So we are just going to copy the code that you would have written for the pop animal and the push animal, and to just change the name to push color and to pop color respectively. It's actually the same, exact same, like literally word for word or line by line, as it were. The only thing that's different is the function name, as it were. So that's why you even see here that it's only 2 marks, right? There's really nothing that you're doing. You're just copying the code as it is and just changing the name respectively. So having done that, you can go ahead and copy the code and paste it inside of the evidence document. Then we are to amend the procedure read data so that it can also read colors from the text file called color.txt, and it's going to use the respective push function, and it's also going to make use of respective exception handling, as it were. So coming back to the read data function, you see that we now have the color top pointer. Earlier on I did say ignore it, but now for this part of the question, we now want to push colors onto the color stack, as it were. So now you can consider this line. We are also resetting it as before to 0, though it's not really necessary, but it's good practice to get into. Then you see that this implementation that we have for reading the animal data is exactly the same as we have for reading the color data, as it were. So the only thing that's different really is the name for of the file that we are reading from, as well as the temporary value or variable name that we are going to be giving our color file, as it were. So this one is color file. Then of course the pushing and everything else really is the same logic, as it were. That's why you even see that it's only 2 marks. Then we have a procedure called output item. that's going to pop the next item from both animal and color. And it's going to output the color and animal on one line, for example, black horse. If there's no data in color, the animal is pushed back onto animal. No color is output. So if there's no data in animal, then we push back the color onto the color stack and we just output no animal. So we have to write program code to implement this functionality. So let's go ahead and look at this function right here called output item. So we are making reference to the global animal top pointer and color top pointer variables. Then we store the popped animal inside of this popped animal variable, and we also store the popped color from this popped color variable right here. Like remember, these values, they are going to be returned by the pop animal and pop color functions respectively. Then in the case that there's no color available, we are just checking to see if popped color is equal to an empty string. Then we are going to check to see if popped animal is not equal to an empty string. So remember, it said here that if there's no data in the color, but there is an animal that has been popped back, popped rather from the stack, we have to push it back, is it, and just output that there's no color. So what we are doing here is we are checking to see if the color is empty, but the animal is not empty. That's what we are doing on line 98 and 1999. So if the animal is not empty, we push back the animal, then we output no color. Then in the case where there's no animal but there's a color, we check to see if the popped animal is equal to an empty string. If that's the case, we need to check if the popped color is not an empty string. So if it is not an empty string, we push back the color and tell the user that there's no animal, associated animal as it were. Otherwise, we are simply going to print the popped color and the popped animal as it were. So that's how we go about that. Of course, you could go ahead and copy this code and paste it inside of the evidence document. Then moving on to D, we have the main program that's going to call the procedure read data. Then it's also going to call output item 4 times, is it? So we have to write program code for the main program. So coming down here, we call read data here. Then we are going to output item 4 times. So instead of having to write output item 4 individual times, we can just make use of a for loop that's going to run 4 times, and we call output item each time. So that's the implementation for D item 1. Then for the last part, we need to test our program and take a screenshot of the output as it were. So let's come back to the script here and just run it. So clear the console, then run this file, and you see that we get that output right there. So of course, you'd go ahead and take a screenshot of this output and paste it inside of the evidence document. So yeah, I think that's just about it for this episode. I'll see you guys in the next one.